In this video, we will see from integration techniques the one what we call integration by parts. This is the result of chain rule. Look, let me use informal. F times g, the function of x, derivative is f prime times g plus f times g prime. From this we got f times g prime is equal to f times g, the whole derivative, minus subtract this one, f prime times g. So integrate both sides. When we integrate both sides, we will get the integral of f times g prime is equal to, look, the integral of the derivative. The derivative of the integral, that will give us the function f times g minus the integral of f prime times g. So f g prime, f prime g. So for the given function as a product, we will consider one as f and the other as g prime. Let's see using example. We will do all these examples, these 4 examples. The first one, that is the integral of this one, x times e to the power of 3x. Here we have polynomial function times exponential function. So which one is better to be f and the other g prime? So whenever you have polynomial times exponential, it's better to represent as f x and g prime e to the power of 3x, the exponential. Now let's see here the solution. Look, polynomial times exponential. Remember the integral of integration by parts. Integral of f times g prime. Informally, I wrote this. That is f times g minus the integral of, look, here it is f. So here we will have f prime. Here we have g prime. Here it will be g. So polynomial times exponential. G prime should be the exponential. So in our solution, always you have to let f of x, that is f of x, our function, the polynomial x, and g prime at x, the derivative function, is a power of 3x. From this, we have to find f prime at x, that is 1, and g prime at x is given. So what is g of x? The antiderivative of e to the power of 3x. E to the power of 3x over 3. If you derive this one, you will get times 3, 3 cancel 3, and you will have e to the power of 3x. Now, after we got this, look, fg, the diagonal here, f times g, x times this one. Therefore, the integral of x e to the power of 3x dx is equal to, look, f times g, x times, therefore it is 1 over 3, 1 over 3 x e to the power of 3x f times g minus the integral of f prime g, the lower row, the second row, that is 1 times e to the power of 3x over 3 dx. Now simply the integral of e to the power of 3x. Therefore, this will be 1 over 3 x times e to the power of 3x minus 1 over 3. Again, e to the power of 3x integral. We have 1 over 3. That is 1 over 9 e the power of 3x plus c. That's integration by parts. The next example. Here we have e the power of x cos x dx. Exponential and polynomial. Here we can choose either of the two. Solution. We need to use integration by parts whenever we have polynomial times trig. Let's, that's f of x be e the power of x and g prime at x be cos x. Then from this we have to find the derivative of f, that's e the power of x, and the antiderivative of g prime at x, that's g of x. Cos x is the derivative of sin x. So we have sin x. So using integration by parts. The integral of e the power of x cos x dx. That is the integral of f g prime. Look, f g prime. Fg, the diagonal, is the power of x sin x, minus the indefinite integral of f g prime, g, the second row, is the power of x sin x dx. Now again we need to integrate this one. Is the power of x sin x dx. So let's do it separately. Let's again m of x, that is the power of x, and n prime at x sin x. So correspondingly we have to find m prime at x, the derivative of e the power of x, and n of x, the antiderivative of sin x, minus cos x. Therefore, the integration of e the power of x sin x dx is equal to diagonal here mx nx, e the power of x minus cos x minus e the power of x cos x minus the integral of the second row, e the power of x minus cos x. This will be plus, this minus. Therefore, e the power of x cos x. Now, let's return back. Let's get back here. The integral of e the power of x cos x dx is equal to this one, e the power of x sin x minus, in bracket, the integral of this one has more than one term, so use bracket, minus e the power of x cos x plus the integral of e the power of x cos x dx. Here you have dx. Now distribute this minus sign. The result will be e the power of x sin x minus minus plus e the power of x cos x minus plus minus the integral of e the power of x cos x dx. Now look, but this is, when we see this one, that's the same as our problem, e the power of x cos x on the left side. Therefore, add this value both sides 2 times. This implies 2 times the integral of e the power of x cos x dx is equal to, look, e the power of x sine x plus e the power of x cos x. So divide both sides by 2. Therefore, the integral of e the power of x cos x dx is equal to, divide both sides by 2. 1 over 2. E the power of x is common. E the power of x. In bracket, you'll have sine x plus cos x plus the constant c. That's the answer. The next example. Find the integral of ln x dx, the indefinite integral. Look, this is an example given under integration by parts from techniques of integration. Whatever. But here we have ln x. So since it is under this category, if we thought that we are going to integrate using integration by parts, what should be f and what should be g prime? Let's see. Ln x, only one function we have here. So we can consider this as 1 times ln x. So solution. Let's f of x, if you consider f of x 1, when you derivate it will be 0. So you can take f of x 1. So f of x should be ln x. And g prime at x, that is 1. From this, you will get f prime at x, the derivative of ln x, 1 over x, and the integral of 1, that is x. Then, using integration by parts, the integral of ln x dx is equal to f times, this is g of x. The g prime g of x. So f of x times g of x, x ln x, minus the integral of this one, 1 over x times x dx. That's the integral of 1. Therefore, the result will be x ln x minus 1 over x times x. X cancel x. The integral of 1 is x. Plus the constant c. So remember, the integral of ln x is x ln x minus x. Okay, the last example, look at here, this one. The indefinite integral, evaluate. This one, sine x cos x is a power of sine x dx. Let's see. Look, sine x cos x is a power of sine x. If I substitute sine x, you'll have cos x dx from integration by substitution. But what if we use integration by parts? This is under the example. This example is under integration by parts. So if I consider integration by parts, I know in the case of, look, what's the derivative of e the power of sine x? E the power of sine x. Sine x derivative cos x is the power of sine x. So the derivative of e the power of sine x is cos x is the power of sine x. Therefore, the antiderivative of this one is known. Now, look, solution. Let's f of x is sine x and g prime at x cos x is a power of sine x g prime. Therefore, from this we got f derivative at x, the derivative of sine x cos x, and what's the antiderivative? This is the antiderivative of e the power of sine x. Look, Derivative is 1. The derivative of e the power of x, e the power of x at sin x, e the power of sin x times the derivative of sin x, cos x. Therefore, the antiderivative of this one is e the power of sin x. So using integration by parts, the integral of sin x cos x is the power of sin x dx is equal to, look, f times g sin x is a power of sin x minus the integral of f prime g, f g prime, f prime g, cos x, this one, cos x is a power of sin x dx. Now look at here, sin x is a power of sin x minus, what's this? Look, we said here the antiderivative of this function is a power of sin x. So it is a power of sin of x plus c. In the next video, I will come up with the other technique, what we call integration by partial fraction.